today. This will help tremendously. So if you look at, if you can still go into last week's assignment, so week 10, let me go ahead and actually share screen here. Just pulled up week, that's wrong class. Let me go back to my dashboard. Just a second. Get quantitative methods pulled up. So even though we're in week 11, I posted this under week 10 last week. I didn't make an announcement about it because I was actually going to on Thursday night and Friday morning. So I didn't get to have the tutoring session last Thursday night, but tried to have it on Friday morning. Nobody was there, but we were going to go over this practice assignment. So if you want, go ahead and go into week 10 and download this document. You're also going to need the chronic smoking data set for that practice problem. So if you're in SPSS, go ahead and download that. If you're not in it, let's kind of move forward, and I'll share my screen and kind of we'll walk through it. But so here's the sorry, I shouldn't say linear regression, should say ANOVA. Anywho, no big deal. We're going over ANOVAs today, so I'm going to walk us through how we do this. We're going to have multiple independent variables. So if you're downloading the data set, essentially what we have here is data on a group of chronic smokers. So when you pull up the data set, what you're going to see is that each participant, they collected demographic data on their age, how many years they had been smoking, daily cigarette use, their quit desire. I was a little confused on this one because in the data set, if we go to our variable view, it's not real clear under quit desire. They didn't identify their values. So it's clearly on a 1 to 5 scale. So I wasn't real sure if one meant that they were highly motivated to quit or if 5 was the anchor. But that's not going to be for today's question. They had resting heart rate. So VO2 max as well. So that meant they got on a treadmill test. It's VO2 max is a measure of maximal oxygen use. And then the treadmill test, they must have put them on there at incremental speeds. They constantly picked up the speed, maybe the incline, and they determined how long could somebody last on this particular test. So, and then as well, I'm not 100% sure what this subgroup SIGS is, but we're not going to mess around with that today. So that's our data set. So essentially what we have here is, how many participants do we have? We had 21 participants in this study. So the first question that it asks us, and this would be very similar to your assignment, Sarah, it says run a regression analysis to determine if age, years smoking, and daily cigarettes significantly predicts results on the treadmill test. So if we just look at this statement here, okay, what do we think are the independent variable or independent variables, hint, hint, and what would be the outcome variable or our dependent variable?
So our outcome, we're looking at the results from the treadmill test, and then the age, years of smoking, and daily cigarettes are going to be those independent variables that are going to predict the results.
I just confused myself. This is a linear regression question. We'll get into ANOVA here in just a little bit. My brain's scattered. This is a linear regression. So essentially what we have is we have 3 predictor variables. In the previous assignment, we had 1 predictor variable, still an independent variable, and then 1 outcome variable. So here we're just saying that we have 3 independent variables. And you're right, age, years smoking, and daily cigarettes, that's going to predict how long they last on this treadmill test. Is that sort of making sense? How this study is being set up? Do you have any questions about that, or is it pretty clear?
No, that's pretty
Okay.
cool.
All right. So I did this on some of the other assignments, and I'll try to do this more in the when I post the answers. I'll try to post my steps. So these are the steps that that we're going to follow in running this analysis. So if we come back over here, let's see if I can move this around. All right, so we need to go up to analyze, regression, and then linear regression. All right, now what did we say our dependent variable is?
The treadmill results.
Treadmill test. Yep, so we're going to move that over here to treadmill. And then we said we were going to take age, years smoking, and daily cigarette use as our independent variables. All right, so we entered all of those. Then, as the steps say here, if it's not designated in the question, and we've kind of covered this before, what should we assume alpha is set at?
0.05.
0.0. That's very, very typical, especially in the social sciences. If we needed to change that, or if we just wanted to double check that, and we could come over here and see what alpha is being set at. Anywho, okay, so we come back here and then we click OK, and it should run the analysis for us. All right, now there's a few things that we can pull from the model summary, the ANOVA table, and then particularly our coefficients. So let's walk through these. All right, so the question about the model, how much of the variance in the treadmill test is accounted for by age, years smoking, and daily cigarettes? So it's asking for the combination of those three variables. And we get that up here in our model summary. All right, so it's saying the correlation between those three variables and our outcome variable is 0.944. That's a pretty high correlation, right? This correlation, as we discussed before in class, ranges from -1 would be a negative correlation to +1, a positive, perfect correlation. -1 is a perfect negative correlation, +1 would be a perfect positive correlation. So this is a strong correlation, very strong correlation. And then when we take R squared, our coefficient of determination, so 0.944 times 0.944, we get 0.891. And in pretty straightforward terms, what that's saying is that about 89% of the variance or variability in the treadmill results is accounted for by the combination of age, years smoking, and daily cigarette use. That's a strong predictor model. That is. So that's kind of how we would answer question number one. Any questions about the correlation or coefficient of determination, that R squared value?
Now, is the R squared value, is that considered part of the variance?
Well, yes, that when we take R squared and we get this 0.891, that's what this question is asking. How much of the variance or the variability in those scores? So according to this model, and that's what statistics is, it's a modeling, it's a way to model relationships or differences among groups, or describing data sets. We're just modeling. So in this case, this three-factor model is predicting about 89% of the variance in our outcome variable, which is results on this VO2 max test, this treadmill test. Another way to say that would be about 11% of the variance in treadmill tests, according to this model, is being accounted for by other variables that we didn't measure. Okay, so it's strong. It's a pretty good model for predicting the results on the treadmill test. So question number 2 asks us, are the three independent variables a significant predictor of the treadmill test? And we would say yes. Now, we don't just leave the answer as yes. Statistics provides us with empirical quantitative measures. So we would follow that, the answer yes up with some sort of empirical support. And that in that case, we would look at our ANOVA table. Our ANOVA table is telling us that this model is a significant predictor. Now we could assess that two ways. And this has been our mantra over the last few weeks. This F statistic, it's just a test statistic. We want that, if we're looking for significance between groups, do we want that test statistic to be really large or really small?
High test statistic.
We want a really large, we want a big test statistic, and we want a really small p-value. Okay, so we set alpha at 0.05. And so what this is saying is that it's much smaller, and we could go in here and we could actually probably click on this table and we could see the exact value, but it is super tiny. I mean, it's much smaller than 0.001, but we would just say that it's less than p equals 0.001. That's rounded, but it is much smaller than that. So as long as 0.001 is less than 0.05, this is a significant predictor. So for number 2, we would say yes, that according to the ANOVA model, and then we would report our F statistic. We would say, well, and actually here, let me pull up the answer sheet. And I will end up posting this as well, so that when students work through these practice problems, they can go back in. So if we were going to kind of write this out, again, we wouldn't just stop and just say yes. We need to back it up with empirical support. So according to our regression analysis, ANOVA results suggested that the 3-factor model, okay, I was significantly predicted treadmill test results. And then we report our F statistic, our degrees of freedom, and our p-value. And we pulled all of that from our ANOVA. We have our degrees of freedom, we have our F statistic, and our significance level, so our p-value, and that's what we wrote out here. So a lot of really good information packed into that one sentence. So is that making sense? Kind of what this question is asking us? Okay. So then what we could do is, because regression is a predictor model, all right, what's the regression equation for this model? Well, fast forward, here is going to be our answer, all right? So y equals our constant plus some kind of a change in our independent variables, okay? So our y, our dependent variable, our outcome variable, is the treadmill test. Our y-intercept, or constant, is going to be 32.27. That's right here in our coefficients table, 32.27. And then we need to figure out what our independent variables, the change in those independent variables. So in this case, we have 0.907 times a person's age, negative 0.801 times years smoking, and then negative 1.935 times daily cigarette use, okay? So since those were negative values, we just subtract. So our model, our predictor model, is 32.27 plus 0.907 times a person's age minus 0.801 years smoking minus 1.935 times daily cigarette use. Those are our 3 independent variables that, when combined, are going to predict, based on our constant going to predict treadmill test results. So number 4, well, let me pause there, Sarah. Is that kind of helping? I mean, because you kind of had some questions about how to read, these models when you had multiple variables. Is that helping? Does that make more sense?
Yes.
Okay.
Yes.
Okay. Then question number 4, because it's a predictor model, theoretically, if we were given a new participant and we only knew, like, let's say, for example, their age, years smoking, and daily cigarette use, we could calculate a rough estimate of their treadmill test results. We could do that. And that's what this next question is going to ask us. It's going to ask us to complete the table below to predict the missing data value. Okay, so for participant number 1, we say they're 30 years old, they've been smoking for 5 years, and they smoke 15 cigarettes per day. All right. Now, if we go back and we just enter those 3 independent variables into our equation, what you're going to end up getting is 26.45. So I'll let you work out the others on your own time. Like I said, I'll post these. But what I did for number 4, for your 4th participant, so we're going to say that this person doesn't smoke. All right. So they're 45 years old, they've never smoked, and they don't smoke any cigarettes per day. We could still enter that person into our study, into the regression analysis, our predictor model. And what we're going to see is that based on those predictions, that they're going to last approximately 73 minutes on this treadmill test. So what we can do with these regression models is, we could, and I think we talked about this last week in tutoring, let's say that you're a tennis racket manufacturer, and you produce a tennis racket that you say, it's a new type of strings, that these strings last longer on average than any other tennis racket out on the market, right? Well, in order to establish that claim, you're going to have to run trials, a significant number of trials on that tennis racket or those types of tennis rackets to be able to demonstrate, how long this tennis racket can last. Well, then what you can do is you can take any other tennis racket that you produce and enter it essentially into your model, and it will predict how long that tennis racket will last. This is very common in manufacturing, in business, using these types of regression models to predict some sort of an outcome. In this case, we're just using the model with multiple independent variables to predict somebody's cardiovascular endurance, which is being measured by this treadmill test. So up to this point, before we move on to number 5, what questions do you have?
So if you were asking us to complete the table, we would just plug in those values that are known that we have into that equation.
Yes, exactly. So for the first person that's 30 years old, you would just rewrite this equation and multiply 30 by 0.907. And then 5 times 0.801 and 15 times 1.935. Make sense? Mm-hmm. Good deal. Good deal. And so, you could even do this with, as long as you have 3 of the variables. Like I could have asked you, for participant number 3, and left number of cigarettes per day blank and given you the treadmill results, and you could predict based on age, years smoking, and treadmill results how many cigarettes that person uses per day. If you just, I mean, basic algebra, you just rework the formula to yield number of cigarettes per day as your outcome or dependent variable. You could do that as long as you had the other variables, the other givens. So yeah, when you go back and practice this, see if you can do those calculations. I'll probably try to add some of some of those type of exercises, example problems into some of the homework as we move forward. So don't be surprised if you see something like that. So we have our same data set, but now number 5 asks us, all right, well, run the regression model again, except with years smoking and daily cigarettes as an independent variable. So essentially it's saying, all right, well, let's back out age and just use years smoking and daily cigarette use as the independent variables. And then repeat questions 1 through 3 for this new model. Now, we mentioned last week in the tutoring session, the more variables, and this is a given, it doesn't matter what the variables are, okay? Because if you throw enough variables into the model, it's going to be a stronger predictor. Does that make sense? Mm-hmm. If we had 100 variables, that's going to be a stronger predictor model than a model with 50 variables, and 50 variables is a stronger predictor than 25 variables. Just like 2 predictors is going to be stronger than 1. But there's always some sort of a trade-off there. Even though more is technically better, sometimes it's not feasible or cost prohibitive to collect data on that many variables. It takes time. It might cost money. So we want bang for our buck, if you will. We want the best predictor model with the fewest variables, in essence, okay? Now, fewest in essence doesn't mean that we just want 1. Maybe we need 2, maybe we need 3, maybe we need 10, I don't know. But that's what statisticians do, is they try to find kind of that sweet spot, right? So what we're going to do now is we're going to repeat this analysis with 2 variables. And I'm going to leave this analysis here. And what I want us to do is we're going to go back to, if I can move all this around, let's go back to our data set. And I'm going to have you walk me through how to do this next regression, but with our 2-factor model. So do you remember kind of the steps?
I think so. So we'll go to analyze.
Yes.
And then, which one is it? We're looking at linear regression.
Yep, we'll go down to regression and then over to linear.
Okay.
Mm-hmm.
Then yeah, our dependent value, we're still looking at our treadmill results. And then for our independent variables, we were just looking at 2 of them. So you'll take block 1 and take those out. Well, yeah, we're taking out age, so just the year smoking.
Perfect.
Daily cigarettes.
Then we click OK. And now our new regression model. So we have our first regression model up here that had our 3 independent variables: age, years smoking, and daily cigarette use. So now we look at our next regression model. All right, so this is our 2-factor model, right? Now this one is saying that what's the correlation? So the combination of the 2 independent variables, what's the correlation with our treadmill test?
Would that be the R value?
Point, yeah, R is our correlation, yes. So 0.913. Now, let's compare that with up here, 0.944. I mean, still both are really strong correlations. 3-factor model is 0.944. The 2-factor model is 0.913. not that much difference. And I'm sure if we backed out one more variable, we would get a little bit lower correlation. Just like if we added a fourth or a fifth or a sixth, we'd get a little bit stronger correlation. Because these are models, we're never going to get a perfect 1.00 correlation. That almost never happens. These are predictions. There's always some degree of error. So, but still 0.913 is really strong. So we see an example here of how 3 variables yields a little bit stronger correlation than a 2-factor model. And we could, again, we could run that with 1 variable. And let's just do that. Let's rerun that real quick. We go to Analyze, Regression, Linear. Which variable do you want to back out? Years smoking or daily cigarette use?
Years smoking.
Okay, so we'll back that one out, and then we'll click OK. And I bet, yep. So you see here with our 1-factor model, daily cigarette use, 0.903. So with 1 factor, we go from 0.903 to 2 factors, 0.913 to 3 factors, 0.944. And we could, like I said, we could then add in a 4th, a 5th, a 6th variable, and we'd see that a little bit more, a little bit more, a little bit more. But what this question number 5 is asking us, it asks us to run this model with only our 2 variables. All right. So we go back here to it's our 3-factor model. So here's our 2-factor model, our 0.913. We see here we have two predictors: daily cigarette use and years smoking. So now we should be able to repeat questions 1 through 3 with those 2 independent variables. So let's pull up our completed work. So I just copied and pasted our output, and that's what we saw in SPSS. So the first kind of question was asking us about the variance. And if we look here at our R-squared value, we get 0.833. So in other words, 83.3% of the variance in treadmill results is being accounted for by the combination, the interaction of those 2 independent variables: daily cigarette use and years smoking. And then, is this a significant predictor of treadmill results? Yes, it is. Results of the regression analysis, our NOVA output, suggested the 2 factors, years smoking and daily cigarette use, is a significant predictor of the treadmill test. And anytime that we report something like that, we always want to follow that up with our F value, our F statistics, so in this case 44.96, our degrees of freedom 2 and 18, and then our P value, which is less than 0.001, but we can just round that to P of 0.001. We know that's a significant predictor because P of 0.001 is less than 0.05. We could have also looked that up in an F table if we knew our F value, right, our degrees of freedom, and our alpha level of 2 and 18 and an alpha of 0.05, but we don't need to look it up because P is so small. As long as that P value is smaller than our alpha level, we don't have to look that up in a table. And then the final part would ask us to write the regression equation. So in this case, our outcome, treadmill test in minutes, is equal to our constant, 48.613, minus 0.361 years smoking, minus 1.2 621 times cigarettes per day. So now if I gave you a similar table as number 4, we could predict treadmill use based on those two variables. Now, which model, which analysis is better, more valid? That's debatable, whether the 3-factor model versus the 2-factor model. And we can see that, yes, on the surface, by an eye test, that the 3-factor model is a stronger predictor. But in the real world, as we talked about, sometimes it's not as feasible to collect data on 3, 4, 5, 100 different variables. So we might end up saying that, no, this 2-factor model is, maybe we argue that it's a better predictor. That's what statisticians, that's what researchers run into when they're doing these types of analysis. You've simply got to make your case for why the 2-factor model is maybe a better predictor than a 3-factor model. So, but that should help a little bit in kind of understanding how, when we have a data set with multiple independent variables, how we can run that analysis and run a regression model on multiple independent variables and one dependent variable. What questions do you have on any parts of that practice assignment?
So the linear regression, now I was just reading through the text, the univariate model, is that something that could be used, or is it just better to stick with linear regression that way when there are multiple independents?
So say that one more time.
So when we're running the analysis, is going through analyze linear regression model, is that the best way to go about when there are those independent variables? Or the text mentioned the univariate, I guess, analysis.
Yeah, I'd have to double check exactly what field is referring to there. For the purpose of our class, we don't get, this is an introductory statistics course. I simply want you to understand basic linear regression, how that works, the concept of regression. Yeah, we're not going to get too deep into multivariate or anything like that. But I'll double check that in the text, and hopefully by the tutoring session tomorrow night, have a better explanation of that for you.
Okay.
So we won't get too deep into week 11's assignment, but let's, if it's okay with you, let me pull that assignment up and kind of have an idea in mind of what we're going to be looking at for tomorrow's tutoring session. So this is probably what you have. We're looking at multiple regression. Simple, when you hear simple regression, we probably only have one independent variable, one dependent variable. When we hear multiple regression, that's kind of that's exactly what we did today. So for number 1, album sales, so just a different data set, it's saying that, okay, album sales in thousands as our dependent variable, and then we're going to include 3 independent variables. And that's exactly what we just did today.
So we would still use that linear regression.
Yep. Mm-hmm.
Okay.
You sure would.
Okay.
You sure would. Mm-hmm.
Plug those values in.
Let me go back to our data set, analyze regression. So you were saying in the text that there was univariate?
Mm-hmm. or maybe it was the videos somewhere in my.
Okay, I'll check it out. But essentially, what we mean by linear, it's a predictor model, and you know how like if we had just two variables like height and weight. If we correlated height and weight, what we're going to see is that there's probably a pretty positive correlation between those two variables. In other words, generally, the taller somebody is, the more they weigh. Now, that's not always. You could have somebody 6 foot that weighs 170 pounds. You could have somebody that's 5'6" that weighs 300 pounds. But in general, we would say there's a positive correlation. So if we graphed out one variable on the y-axis and one variable on the x-axis, what linear regression means, it's going to put a line of best fit through that model, right? That's what linear regression does. It tries to find that best one fit. Well, we could have a model where, let's say that as the data is spread out, it's not a perfect line. Let's say our data could be scattered in like in a curve, okay? Meaning that low scores on one end, that a low score on one variable is also a low score on the other variable. But as you increase the value of one variable, scores go up. But then at some point, scores start to trail off. There can be different shapes to our model. All linear regression is saying is that it's trying to fit a perfect line through that model. It doesn't assume any kind of curve or exponential relationship in those two variables. It's going to say that there's a direct linear correlation. There's different types of regression that will allow us to assess for exponential or curvilinear. I just want you guys in this course to understand the basic concept of regression, which it's asking us for the relationship amongst variables, and it's going to predict some sort of an outcome. And we're using linear modeling to do that. That's as deep as we're going to get into regression in this class. But yeah, for this week's assignment, week 11, you're working with album sales, and just exactly what we went over in today's tutoring session. That's what you're doing. Number two asks you to, well, number one asks you about the variance. That's our R squared value, correct?
Mm-hmm.
Number two asks us for the regression model. And then number three asks us, is the regression model a significant predictor of album sales? And then you have to support your answer. Those are all the steps that we just went through for chronic smoking data.
Now, using that linear regression for, say, like a problem like number 4, when we're looking at between groups and within groups, would that still work and give the, I guess, that output that we're looking for there?
So say that one more time.
So when we're looking at between groups or within groups, we'd still go through the same steps in SPSS with the analyze linear regression.
Yes. And you're going to get very similar output. Now, the results might change a bit, but your steps in the analysis, you're going to have one dependent variable. You're going to have 3 independent variables. And so just like we did for our regression analysis here, you're going to get a model summary, an ANOVA table, and coefficients, and you'll have 3 independent variables that are predicting our one outcome variable, which in this case is it's asking us about album sales. So in other words, this album sales data set, they collected data on a variety of different variables. For example, what was the company's advertising budget? How many airplays did a particular song get? For a band, they gave people questionnaires or surveys and asked them, okay, on a particular scale, maybe it was 1 to 5, how attractive is the band? Okay, and so we're going to look at those 3 variables in combination with one another, and is that going to predict album sales? And that would be a very realistic question for for a recording company to ask.
So will we use, I think this was in chapter 9 as well, where we have to label the variables as far as, is it a fixed variable? Is it a random variable? Is it a covariate?
So let's go back. So when you have your data set, and a lot of these data sets that come from the companion website, they've already listed the measure. Now, in our class, towards the beginning of the semester, we talked about various types of variables, like ordinal variables, ratio variables, nominal variables, continuous variables, things like that. SPSS essentially kind of categorize them one of three ways. Okay, if something is a continuous variable, we're going to call that a scale variable according to SPSS. If something is an ordinal variable, like you finish first, second, third, fourth, or like freshman, sophomore, junior, senior, something like that, those are ordered. All right. Nominal, we can also indicate that here. So is a person in section 1 of a class versus section 2 of a class. So we need to tell SPSS what type of measures these are. A lot of times if you're given the data set, it's very likely that whoever created the data set, in this case, I don't know if it was the textbook author or somebody, it doesn't really matter. They've indicated the measures. If you're inputting your own data, like say that you were conducting this study, you need to tell SPSS what type of measure that is. Does that answer your question?
Kind of. I guess mine was more let me pull up my SPSS. But okay, so when I had the data and I went to analyze, and then I think what I was doing was the general linear model with the univariate. And then from that selection, that's where it was asking for the fixed factors, the random factors, and the covariate. So I didn't know if that was the test I would need to run for any of these.
Go to just regression. Don't go to general.
Okay.
Models. Just do it from regression. There,
that's where I was struggling.
Yeah, I'm not an expert on SPSS, by any means. There are probably bells and whistles that this has that, people out there with a PhD in statistics don't know all the ins and outs. SPSS is an incredibly powerful statistical software program. Okay. For this case, our graduate course is an introductory course to statistics. We're barely scratching the surface here. So you're going to run regression, just a general linear regression. Anyway, yes, that's okay. What you're doing.
It sounds like I was making things complicated
kind of
when I didn't have to, and it was confusing me.
Sure. Okay. So anyway, yeah, that should help you with at least the first part of the assignment. Tomorrow night in the tutoring session, maybe we'll talk a little bit more about more on analysis of variance. What else do we get into? More one-way ANOVAs. We've already run our analysis for. We did something here with final exam scores in a kinesiology class, but we only had two class sections, Class A and Class B. Well, now what if we have a third class section? So now we can't run t-tests. We have to run analysis of variance. So we'll try to get into some of that tomorrow night in the tutoring session so that we understand how to do that. And then we'll see what we have time for factorial ANOVA, because that's the last part of our assignment, I believe. Yep. So you feel more confident with part 1 of the assignment for this week?
Yes,
Good,
I think
good.
so. I think I was just overcomplicating things.
All right.
So.
Well, statistics is not the easiest thing in the world, but It is very doable when you start breaking it down and kind of understand, why we run these analysis and how to run them. SPSS, all we do is input the data, point click, tell it what analysis to run, and then it's up to us to interpret those models. And that's exactly what we worked through today. So yeah, I hope you have a better understanding of what regression is, as a predictor model, looking at the relationship amongst variables, and is it a significant predictor of some sort of an outcome, and then how we interpret that in SPSS. So, yeah, see if you can work on that. Continue to work through, the practice problems, and yeah, get to work on this week's assignment. And if you want to join us tomorrow night for the tutoring session, we'll go a little bit deeper.
All
Sound good?
right. Yep, that sounds like a good deal.
All right. Well, good stuff. We'll hopefully see you in another tutoring session. And yeah, good luck.
Awesome. Thank
All
you.
right. Bye-bye.
Bye.
See ya.